Hello everyone, welcome back. I'm back with another tutorial. Today we're going to see how to run a ANOVA test in R and also see the assumptions. So as you may know, ANOVA stands for Analysis of Variances, and it is a statistical test to see how a dependent variable changes according to the levels of one or more categorical independent variables. In another way, ANOVA tests whether there is a difference in means of the groups at each level of the independent variable. There are different types of ANOVA, but today we only check the one-way ANOVA. You see the null hypothesis here is that there is no difference in means of these groups, and the alternative hypothesis is that the means are different from one another. So for today's example, imagine that we are analyzing data about crop yield from a region. We have 96 number of different amount of crops being harvested. And so it is the target variable for our example. We also have three independent variables: density, block, and fertilizer. Density, which is the planting density, or the number of individual plants presented per unit of the ground area. And it has two levels, 1 and 2. Block is the planting block, and it has 4 different levels, 1 to 4, and it is based on soil texture, moisture, sunlight, and so on. And finally, fertilizer, that has 3 types or 3 levels of 1, 2, and 3. In this video, we just want to know the effect of fertilizer variable on the amount of crop yield. For estimating the effects of other variables like density and block, we need to run other types of ANOVA, which I'll do that in the upcoming videos. So for now, go ahead and open an R script in RStudio. As always, we need to install and load some packages. If you haven't installed these packages already, then do that by install.packages command for each of them, and then load them simply by library command. We need ggplot2, ggpopr, tidyvars, and some statistical packages. ggplot2 is for producing statistical or data graphics, charts, bars, and ggpopr makes it possible to automatically add p-values and significance levels to box plot, bar plots, line plots, and so on. And tidyvars is for transform at better presenting data. Load the data using read.csv command after setting the work directory, and then use summary to get a sense of the data. You see the result in console window. You know the result is not that perfect because density, block, and fertilizer are categorical variables, and the only quantitative variable with a valid numeric summary is yield. So move on. For this example, as I said, we are modeling crop yield as a function of the type of fertilizer used. So we use the AOV for the model and put it in one way, run it, and then use summary of one way to get the summary of the model. So the model summary first lists the independent variable being tested in the model, which is fertilizer, and the model residual. The df column displays the degree of freedom. The sum square column displays the sum of squares, the total variation between the group's means and the overall mean. And the mean square column is the mean of the sum of squares, calculated by dividing the sum of squares by the degrees of freedom for each parameter. The f-value column is the test statistic from the f-test. This is the mean square of each independent variable divided by the mean square of the residuals. And finally, the probability of greater than f column is the p-value of the f statistic. This p-value shows how likely it is that the f value calculated from the test would have occurred if the null hypothesis of no difference among group means were true. So, as you can see, the p-value of the fertilizer variable is less than 0.05. It means that the type of fertilizers being used does have a real impact on the final crop yield. So, as you may know, ANOVA tells us if there are differences among group means, but it does not tell us exactly what the differences are or which groups are different from one another. So to find out this, we perform a Tukey's honestly significant difference or Tukey's HSD post hoc test for pairwise comparisons. So run this line and you see the result in the console window. From the post hoc test results, you see the p-value for comparison tests between fertilizer groups 3 and 1 and between fertilizer types 3 and 2 are less than 0.05. So they are statistically significantly different, meaning that fertilizer type 3 is different from 1 and also fertilizer type 3 is different from type 2. So that was the ANOVA, but after all, let's check the ANOVA's assumptions. We should have done this before running the post hoc test, but it is okay. So first assumption is having no outliers. We draw the box plot to see if there is any outliers or not. So run it. And you see there is only one outlier in fertilizer type 3, which we can ignore it for now. And move on to see the other assumptions. The other assumptions are normality, independence of data, and the equality of variances. So the data are independent as there is no any crops used two types of fertilizer in the process of growing, and each grow as a result of one type of fertilizer. So it means that they are independent. But for the normality assumption, there are two approaches in order to be checked. The first one is analyzing the ANOVA model residuals to check the normality for all groups together. This approach is easier and very handy when we have many groups or if there are few data points per group. And the second approach is checking normality for each group separately. This approach is used when we have only a few groups and many data points per group. I'm going to show you both these approaches. We need to use QQ-plot and Shapiro-Wilk test for both of them, but it is okay to just only use QQ-plot. So go ahead and draw the box plot of residuals. First, we need to build a linear model, then run it and also run this line. So you see the plot. In the QQ plot, all the points are approximately along this line. So we assume the normality. This can also be supported by the results of Shapiro-Wilk test, as the p-values are not significant, so the residuals are normal. For the second approach, or for checking normality by groups, we draw the QQ plot for each fertilizer or for each group. And you see all points are along the lines again. So we conclude that they are normal. You can again make sure by running Shapiro-Wilk test. And you see p-values are not significant. So they are normal because all of them are greater than 0.05, so we fail to reject the null hypothesis. For checking the last assumption, or for checking the equality or homogeneity of variances assumption, we have two approaches again. One, plotting the residuals versus fits, and second, through Levene's test. So run this line to get the plot. And The plot indicates that there is no relationship between the residuals and the means of each group or fitted values. So this assumption is also met. Through the second approach, I mean the Levene's test, you see the p-value is greater than 0.05, so we fail to reject the hypothesis of homogeneity of variances, meaning that this assumption is also met. And that was it. That was the process of running one-way ANOVA test and checking its assumptions in RStudio. I hope you found it helpful, and if you have any further questions, feel free to ask me in the comment section below. And I'll see you in the next video.